I have two papers here that correct both the Smithsonian Environmental Research Center and the National Atmospheric and Oceanic Administration about how Earth's atmosphere formed. I had to do it. It was just sticking out of me. I had to do it. Hi, Celeste. I had to do it. But the second of the two, correcting Noah's page and how the Earth's atmosphere formed. It's sort of a, it was a website, designed to explain to kids what's going on here. But basically, they have it as Earth forming in stages. They have a first stage, a second stage, and a third stage. And I want to read this whole thing out to you because there's a lot of things in there that I noticed. One thing in particular that they did get a few things right here. One thing in particular that I saw that they got right was that the first stage for Earth's atmosphere formation, it says here, Earth's original atmosphere was probably just hydrogen and helium because these were the main gases in the dusty, gassy disk around the sun from which the planets formed. That second half is wrong, from which the planets formed from around the sun. We know that's false because the Genesis spacecraft disproved that the Earth's material came from the sun's material. The isotopic abundances don't match. Basically the elements on the Earth and their ratios of heavy hydrogen, heavy nitrogen, heavy oxygen do not match that come out of the solar wind. So that was falsified, that they haven't changed it yet. But anyways, they got the fact that the Earth did start out as mostly hydrogen and helium. Everybody that watches these videos knows that. The majority of the hydrogen helium also was plasmatic. The entire Earth was a giant plasma atmosphere. I don't want to read this whole thing out. I just want to overview something really cool just to get people's mind oriented in that direction. Juno is currently orbiting Jupiter as we speak. There's lots of chemistry happening in there. I think Jupiter is around 700 million years old. And for those that are curious, those that actually want to know what Earth looked like when Earth was 700 million years old, about 3.8 billion years ago, right where we stand, the atmosphere was incredibly thick and incredibly toxic and pressurized. This is what the Earth's atmosphere used to look like. This is what the Earth used to look like 3.8 billion years ago. See all that chemistry going on? This thing's going to start turning blue. The whole thing's going to start turning blue as it shrinks. And all the chemistry is going to change over time, over many hundreds of millions of years. Jupiter is going to move to look like Neptune. Neptune's probably around 1.1 billion years old. So Jupiter probably has around 400 million years to go before it starts resembling Neptune in mass and atmospheric composition. And of course, Neptune, being at 1.1 billion years old, has itself around 3.4 billion years to go before it resembles Earth, an Earth-like object. So we're talking immense timescales. And I wrote that in this other paper here. Why do some planets have atmospheres and others do not? The truth about the Hadean Eon. And the Hadean Eon is the beginning of the Earth's evolution. The astronomers and geologists, they say that the Hadean Eon was when the Earth was magma. The entire surface was liquid rock. But that's just not true at all. The Hadean Eon, the very earliest eon, right after the Earth star was born, was when it was incredibly plasmatic and hot and big. The Hadean Eon is what all young stars are currently in right now. Long before they've even formed a solid surface or a liquid surface or even a gaseous object. It was mostly plasma during this time. It was extremely hot and it was extremely energetic and huge. Very, very, very big. Huge. But I have here, let's see, let's go ahead and read, what's the graph, blah, 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 blah. Okay, so basically, what's throwing astronomers off is that they're assuming the Earth was always its current size. So when they do measurements and when they try to explain how atmospheres have evolved, they try to make the Earth going through these strange stages without actually looking and observing at the young Earths in our solar system and around the galaxy. They just ignore all those and they explain them all away. Oh, there's a gas giant. Oh, those are luminous stars. They're, doing whatever. But those are young Earths. It's pretty obvious. And it's really throwing astronomers off. The majority of Earth's existence up to now has been very close to its current size. That's correct. The majority of Earth's existence has been, while it was an ocean world up to now, about 3 to 5 times its current mass for about 3 billion years. But the first 1.5 billion years that the Earth has been around, it wasn't Earth-like at all. At all. It was a gas giant. And before gas giant stages, it was a young hot star. Remember, this is a logarithmic. This is a log scale. This isn't linear. These little scales right here should be stretched out significantly as you move down the graph. But for that first 1.5 billion years, all the way up to Neptune right there, that's 1.5 billion years right there. But then after that, it increases significantly. This time on this graph, like a centimeter right here, is far, far, far longer than all this. So a centimeter right here would be maybe like a millimeter right here of space, because it's a log scale. It's log scale on both the y-axis and it's log scale on the mass axis, the x-axis. But it's very important to understand, and the reason why I wrote these papers is to understand, to correct the NOAA people, to correct the Smithsonian people, is that Earth's atmosphere evolved from a stellar atmosphere. And we know this because we observe the stellar atmospheres and we can take measurements of them, and they're luminous. And as they cool and collapse on themselves, that atmosphere undergoes differentiation and changes in combining chemical elements together to make new elements, or combining elements together to make new molecules. And those molecules grow in complexity as the object evolves. Anyways, I don't want to make this talk too long, but I will put these links to the bottom of this page, and how it should read on the Smithsonian Environmental Research Center page is exactly this, and this is what I want to get across to people. When Earth was a newborn star 4.6 billion years ago, its entire composition was a homogeneous plasmatic atmosphere, mostly consisting of hydrogen, helium, and oxygen, as the sun is now. It did not have a surface. As the Earth cooled, the plasmatic atmosphere cooled into gas and slowly dissipated over hundreds of millions of years during the Hadean Eon. After about 600 million years, and the Earth cooled down past the brown dwarf stages of metamorphosis and stopped shining strongly in the visible spectrum, water could then begin forming from the chemical combination of the star's hydrogen and oxygen gas, as well as methane, hydrogen sulfide, and carbon dioxide, because it was cool enough to form. This further helped the deep interior of the gas giant cool and begin forming a solid surface. And that's basically it. That's it in a nutshell. We have to look at these stars as being a very holistic thing. It's all together. We just can't chop it up into bits and pieces and say, well, this evolves this certain way, this evolves this certain way, this evolves this certain way. No, they're all a long, continuous spectrum of atmospheric evolution. And the atmospheres that evolve past a certain point, they start dissipating as well. And they start changing even more in composition. And if the carbon dioxide can't be recycled into the ocean, as what's happened to Venus, that CO2 will be built up in the atmosphere, and it will start heating up and it will sterilize the surface. But that's for another talk. And then eventually that CO2 will start dissipating away, and the star will be a cold, dead rock, similar to Mercury, after it's aged trillions of years. But that in a nutshell means that just because the astronomers say that an object orbits a younger star means they're all formed from the same interstellar dust cloud, doesn't you can't sit there and declare something like that when all the evidence rails against it. Mercury is vastly older than a lot of the large objects in our solar system, and it's vastly older than the sun. And the Earth is vastly older than the sun as well. And Jupiter, Saturn, Neptune, Uranus, those are middle-aged stars that have evolved for hundreds of millions of years. All right, guys, I'll link these pages to the bottom, and hopefully people can understand what an atmosphere really is. It's a leftover remains of when the Earth was a much hotter, younger star. It's evolved to this point over 4.5 billion years, and we're breathing it in. All right, later.